Hello, I am Seema and welcome to part 16 of the chapter Chemical Kinetics. The topic of this video is the effect of catalyst. Before I discuss the effect of catalyst, let us understand what a catalyst is. A catalyst is a substance which is added to a reaction, and the purpose of adding this substance is that it is neither a reactant nor is it a product. It is only present there to help the reaction to take place. You know, you can liken a catalyst to a teacher. You are students, you are here to study. When you came to this grade, you had the knowledge of the previous grade and you will be moving on to the next grade. And me as a teacher who's teaching you this particular subject for this particular academic year, I am only helping you to gain that knowledge. The knowledge is there in the books. You already have the previous knowledge and you would be moving ahead to gain more knowledge. But during this time when you are reacting, let us say that this one academic year is a chemical reaction. During this reaction, I'm going to help you just understand the subject. So and after the year passes, after you've understood, you've appeared for your exam and you clear the exam, you move on to the next class. That is, the reactant that came to me from the previous class was here. It moved on as a product to the next class, but the catalyst remained where it was. It interacted with the chemical reactants. And during the interaction was very interesting. There was a proper interaction, like there were bonds. We built a kind of a relationship where you understood what I said and I understood what you needed. And in this way, a kind of an intermediate was made, an intermediate state was built during this academic year. And after you had achieved that knowledge that I wanted to give you, you moved on to the next class and I quietly moved back and I stayed where I am and you moved to the next class, so you became the product. Till then, the new reactants were ready to come to me. So they came in and I started doing the same process started. They came with the knowledge of the previous class, would move to the next class, but I again get involved with them. I teach them till they gain that knowledge and they move away and I again retract to work again on the next set of reactants. It is somewhat like that in the chemical world. The reactants and products are the participants of the reaction. The catalyst is only a helper, an added substance which will help that reaction to proceed faster. And what is the reason that it helps it to proceed faster? You have the books. You could have studied on your own. There is no need of a teacher really. You know how to read and write. So there is no need of a teacher. So why do you actually need a teacher? Because when a teacher explains what is there in the book to you, it kind of becomes easier to understand. So the job of a catalyst, the reaction could have taken place because the reactants are there and the products are there. But the catalyst helps to make it easier by decreasing the energy of activation. So you might, if you just sat with your book, you might have had to put a lot of more effort to understand. But the teacher, by making this, by working a little for you, he simplifies the subject for you. And therefore, you have to apply less effort to understand the subject. The same thing happens. The catalyst, it reduces the activation energy and therefore it becomes easier for the reactants to cross the threshold and form the products. The reactants, you remember the energy diagram that we had? The reactants have this energy and the products have lower energy. In between, the reactants, they form an activated complex, which is known, and this energy is known as the activation energy. So the activation energy, the reactants had to work hard, and that work is the activation energy. They have to put in that much of energy, and then once that complex is formed, then the energy, the reactants or the complex automatically starts moving towards the formation of products. That is when you sit for an exam and you result in the formation of products. And this is where a teacher comes in or a catalyst comes in. When a catalyst comes in, the energy, it reduces, the activation energy goes down. So it becomes, now the reactants had to cross a higher barrier, but with activation energy lowered, the reactants, the energy barrier is smaller and it becomes easier for the reactants to go towards the product side. So a catalyst is a substance which is added to make a reaction easier. There are some examples of catalyzed reactions. Hydrogen peroxide gets converted into water and oxygen. For this reaction, if you use potassium permanganate as a catalyst, the reaction takes place much more easily. In cars, if you know, in the exhaust fumes of cars, the unburnt fuel sometimes produces carbon monoxide. And carbon monoxide, even in 6 parts per million, is highly toxic. Therefore, near the exhaust, a catalytic converter is fitted, and the job of the catalytic converter is that it is a converter that converts the carbon monoxide produced into carbon dioxide by oxidizing the carbon monoxide. So, since it is catalyzed, and what is the catalyst used in it? It is platinum. So, with platinum catalyst, this reaction becomes easier, and it occurs at that temperature where the exhaust fumes are coming out. The carbon monoxide would get converted into carbon dioxide, and carbon dioxide is not at least it is not toxic, although it may raise the temperature of the world, resulting in global warming, but it is not toxic in the sense it's not poisonous. There are enzyme catalyzed reactions that take place. And the human body is like a super machine. You study biology with the human body, you study chemistry, it is nothing but a factory of chemicals. And in a factory, physics is all important and everything is mathematical, all the quantities are really measured. So, in the human body, most of the chemical reactions that take place are catalyzed because the human body is maintained at a certain temperature. For reactions to occur, for example, burning of food in a fire would take place at hundreds of degrees of temperature. But in the body, at a much lesser temperature, the food has to be burnt. So it has to be catalyzed. And the catalysts in the human body or in any organism are known as enzymes. So you have enzyme catalyzed reactions, and biological reactions are usually enzyme catalyzed. Fermentation is an example where catalysis is used, enzyme catalysis is used to carry out the fermentation of sugars to give you alcohol. Another example is KClO3. It gets converted into KCl and oxygen, or it gets decomposed, and for this decomposition reaction you require manganese dioxide as the catalyst. So we find that the use of catalysts is a very common thing. And why do we use catalysts? I'll again tell you how does the catalyst act, the action of a catalyst. The catalyst makes an intermediate with the reactants. And this intermediate complex that is formed, that intermediate complex then decomposes to give you the products. And this intermediate complex is made in such a way that the energy required, the energy of activation that would have been required without the catalyst is far more, but this intermediate complex has energy lower than that. Therefore, this intermediate complex is achieved easier. Remember the example that I told you in the beginning, that of a teacher. So, the intermediate complex, the energy of activation with a catalyst, the energy of activation decreases, and therefore the threshold or the energy barrier is smaller, and therefore it is easier for reactants to jump over the barrier and form the products. So, in this graph, if you have the reaction coordinates on this side and the potential energy of this side, on this side, you know what reaction coordinate is. As the reaction proceeds, what is the energy of the system? So the overall energy, initially you only have energy of reactants. When they start reacting, they form the activated complex, and that is that energy which is required to form the activated complex is known as activation energy. And then the reaction starts moving towards the formation of products, and the energy, and it loses energy, that energy of activation. Now remember, whatever energy of activation is absorbed, it is usually given out. It is given out and it results in the formation of products. I will not get into thermodynamics here, where I explained the case of endothermic and exothermic reactions also. For that, I would encourage you to watch the previous videos. But right now, it is important to remember that when you add a catalyst, the activation energy decreases, and therefore the catalyst helps the reaction to take place faster or easier. Naturally, the amount of time that is required to increase this energy to this point and the amount of time that is required to increase the energy of the reactants to this point, this one would be lesser. So now moving ahead, let us understand a few salient points about catalysts. A small amount of catalyst can catalyze large amounts of reactions. As I gave you that example that the teacher stays there. You came to the teacher for one academic year. And when you moved as products to the next class, the next students came in. So it was just one. Let us say you were 30 students in my class. So there were 30 reactants who resulted in the formation of 30 products, but there was only one teacher. So just one catalyst, or rather a little catalyst, goes a long way to help the chemical reaction, a large amount of chemical reaction. Now after, not only did I help 30 students in 1 year, the next year I am going to be helping the next 30 students who come into my class. So in that way we say a small amount of catalyst can catalyze a large amount of reaction. Let me give you one more example. Have you seen a traffic policeman standing at a crossing? The cars are coming and the vehicles are coming and they are going all their ways, and the traffic policeman is only acting as a catalyst. He's helping them, okay, you go this side, you go that side, you go. He's regulating the traffic. So once the car moves, the job of the catalyst is done. The traffic policeman is only helping you to get to move on from that side to that side. So if the previous side was the reactant side and the final side is the product side, the catalyst only helped you to move. So you are only in one car. Imagine the thousands of cars or vehicles that crossed that crossing from morning till night, or during the 8 hours of duty that the traffic policeman was standing there and guiding them. So one catalyst or very little catalyst can actually help a lot of the reaction to take place. A small amount of catalyst can catalyze a large amount of the reaction. The second point to remember about a catalyst is it does not alter the Gibbs free energy. The energy required to do work, that is not affected. Remember, the enthalpy of a reaction is also not affected by a catalyst. The job of the catalyst is only to decrease the activation energy. It only makes the reaction easier. It does not. Now, I can only make the chapter easier for you. How much you study and how much your preparation is, how well would you perform in the exam would not depend on that, because I am doing the same effort for every child. So out of the 30 students, some may be getting very good marks, some may be doing average, some may be doing worse. So the job, on the whole, the energy change that takes place in the reaction, that is not affected. The energy, the enthalpy of a reaction would be the energy of reactants minus energy of products, or energy of products minus the difference between the two energies. So that would be the enthalpy of the reaction. Similarly, the free energy change that takes place in a chemical reaction, the catalyst only altered the activation energy, and therefore the activation energy gained, activation energy lost, that does not count. The overall energy change, the Gibbs free energy change in the reaction, is not altered by the presence of a catalyst, because the catalyst itself is not a part of the reaction. It is only helping and moving out, like a coach in the football field. Another thing, it does not catalyze non-spontaneous reactions. A catalyst can only help a spontaneous reaction. Now, I am on YouTube. I am making these video lectures. If you really want to study, you might watch the entire video. But if you do not want to study, you would not watch it. There's nothing. I can only affect you if you want to be affected. If you want to study, only then I teach you. So unless and until the reactants can actually form a product, the presence or no presence of a catalyst, let us say there are two people who are absolute enemies. Come what may, they will never be friends. Like they are like day and night, light and darkness. They cannot exist together. and we bring in a catalyst. We bring in the moon, okay, the sun and the, let us say, the black hole. They are together, you to make friends, turn them into friends. Whatever the moon may do, it cannot turn the two into friends. So if you, let us say there is a car that has to cross, and it decides that it is not going to cross, even if the traffic policeman keeps telling him, okay, go this way, go this way, go this way. He says, no, I'm not going. He's stubborn. So what happens? Whatever the catalyst may do, the reaction will not take place if the reactant does not want to react. That is, if the reaction is not a spontaneous one, it doesn't want to react, the catalyst cannot help a non-spontaneous reaction. I cannot help you if you do not want to study. I can only help you if you really do want to study. It does not change the equilibrium constant either. When there's a reversible reaction, what did the catalyst do? It reduced the activation energy. In a reversible reaction, the reaction can proceed in both the directions. So for the forward reaction, the activation energy is this much. But for the backward reaction, the energy of products is here and the intermediate complex is here. So for the backward reaction, the energy of activation is far more. Do you see? For the backward reaction, the energy, this is the energy of activation. The energy of activation for backward reaction is this much. The energy of activation for forward reaction is this much. Now, if you add a catalyst, the energy of activation decreased. It became only this much for the reactant. But for the product, the energy of activation also decreased. This was the energy of the product. If you add the catalyst, the energy of activation decreased. So what happens? The addition of a catalyst decreases the activation energy on both sides. It decreases the energy of the forward reaction, and it also simultaneously, by the same amount, decreases the activation energy of the backward reaction. So what will be the effect on equilibrium of this? That equilibrium for such reactions, for reversible reactions, would be achieved faster if you add a catalyst. Because the catalyst is only going to make the reaction easier. It doesn't care whether the reaction is a forward reaction, or are you the reactants, or are you the reactants. Whoever comes, I'm just going to help you to cross easier, because crossover is not the right word, to cross easier, because covering the jumping over the energy threshold would be easier as it is lower, the energy barrier on both sides. So the presence of a catalyst decreases the activation energy for both the forward as well as the backward reaction. So it does not change and therefore the equilibrium constant, it will help the reaction to occur faster. But the equilibrium constant, that is the concentration, when the concentrations of the reactant and the products becomes constant, that will remain the same. So it does not affect the value of the equilibrium constant. And what is equilibrium constant? K is equal to the concentrations of the products divided by concentration of reactants. That remains the same. Only the equilibrium is achieved faster. So it only helps to achieve the equilibrium faster. The catalyst, it catalyzes both the forward and backward reactions in a reversible reaction. I explained this to you, that because the presence of a catalyst is only decreasing the activation energy. It doesn't matter whether the reaction is going forward or is the reaction going backward. Even for the backward reaction, the activation energy has been decreased by the same amount by the addition of a catalyst. Now we do understand what would happen if we take the Arrhenius equation. How do we understand the action of a catalyst? If you look at the Arrhenius equation, the rate constant is equal to A, the Arrhenius factor, into e to the power of minus EA over RT. So the presence of a catalyst decreases EA, the activation energy, and this is a negative value. So if a negative value is decreasing, it means the rate is actually becoming positive. Rate is increasing, and since it is exponential, the rate will also increase exponentially. So the addition of a catalyst to a reaction decreases the activation energy, and since as the energy of activation decreases, the rate of the reaction increases. So this is the role of a catalyst in a chemical reaction or the effect of a catalyst in a chemical reaction. I hope you found it helpful and you understood it. If you did, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching and bye-bye for now.